Hello, today I would like to show you one of the best analog multimeters that you can get. This device was made in Poland. The model number is V640 by Meratronik. It was made in the 80s. I believe this is the date code 1982, and even nowadays this device have quite unique feature that's making it still a very good device that in some aspect blowing away any of commonly used digital multimeters. So these have a couple of uses that I'm going to discuss with you, and I'm going to tell you exactly why. I've got this set. As you can see, I've got a crazy amount of accessories that you can use for different measurements. The two main most important function of this meter that make it stand out from everything that you can buy from cheap China. This doesn't imply that you cannot get meters with that function, but in general they are going to be a very extremely expensive specific meters made for a purpose. And yeah, the interesting story is this device back then was so good that Marconi Instruments, the company that you most likely know from radio test sets, like industry standards for any radio communication testers, sold them under their own brand. The most important part that this meter have is very high impedance, and it's stated on the meter itself. If you can see, the resistance is 100 mega ohm, and this is not a mistake because most generic cheap Chinese meters that are using same chipset, same components, they are 10 mega ohms. So as you can see, you've got a 10 times more impedance. Why this is important? That's very important if you are checking like a radio circuitry that you've got a high voltage but at extremely low current. When you've got a power supply that can deliver a very tiny amount of current, the good example is going to be a voltage capacitor multiplier. You can have get a high voltage but at very low current. The good question would be, what does a high impedance do for you? You can imagine an impedance as a resistor that is sitting directly across your leads, and if you've got a power supply that can generate, for example, mostly a high voltage, like for a tuning circuitry in radios, then they deliver a really tiny amount of current, like when you've got a capacitor diode multiplier. They are not really powerful, and if you put a 10 mega ohm resistor across, you are loading the power supply, and that is going to affect the voltage that you are reading and take it down depending on the current capable of supplying by the power supply. So for example, you put your meter, you take a look that it should read a 100 volt, but it reads 80 volts, for example. And you think, okay, I need to do alignment. You grab a screwdriver, you turn the volume up, you read 100 volts. You're happy, you disconnect the meter, you put it back to the radio, and the radio is blown. And why is that? Because you've got like a 140 volts, because you were loading that by a low impedance meter. So it's 100 mega ohms is going to be good for almost everything and do not affect the measurement. This doesn't mean that having a high impedance meter is going to be good for all situation. I can easily name you situation where it's going to be a problem, like for example where you are measuring a battery. You don't want actually to measure the open circuit voltage, and you would like to measure it under some load, so it can drag the voltage down depending on the battery size and the capacity. And they are making a specialized meter that have built-in resistors, and they load battery to drag the voltage to the more real scenario where there is a load apply, and you are reading that. Also, when you've got like wires in the installation, you might have situation that it's inducting a voltage across those wires, and with a high impedance meter you can read something that virtually does not exist because it have a really tiny current. They are making modern meters that have got a specially designed button for that. That's called low impedance, and you press that button and you are introducing like a resistor across, and you are loading the circuit, and you've got a more realistic reading. So if you know what you are doing, this high impedance is 100% most important part of purchasing it. Second thing is that this meter is capable of making measurements up to 1000 megahertz. And this is absolutely true. You can measure the HF, UHF, VHF up to almost the ISM 800 something megahertz band. If you've got a signal generator that is like a crystal oscillators or any other source of a signal, you can measure the output voltage combined with the high input impedance. You are going to make sure that you are not going to stop the oscillator from working, and you are not going to put too much load on it and prevent it from working. And you can make that happen with a regular meter. You can also measure almost any transmitters with that, even if they are not 50 ohms. You can basically solder correct resistor across the output of a radio. You can then probe and measure the voltage across, and up to 1 gigahertz you will read the voltage. You are multiply that, you are divided by a 50 ohm, 75 ohm, or whatever the value is, and you are going to get the output power. So I purchased this meter only for measurement of like RF equipment, and for voltages and all of that I'm going to stay with my Voltcraft benchtop meter. Let's take a look at the meter. As you can see, the scale is absolutely amazing. You've got a mirror on the center to help you with correct reading the value. You've got different scale for different modes, and as you can see, it can measure the resistance, you can measure in a microamp, and you can see that you can have a full scale of 1.15 microamp. And we are going to take a look at this in a second, why it is possible, and that's because of that BNC connector. You are using a BNC shielded cable, so you are not going to be affected by things that are going on in your lab. You can also measure the dBm for radio applications. You've got millivolts, and full scale can be as low as 1.5 millivolt. And this is how it looks like, and it can measure up to a really high value in the giga ohm range on the resistance part, and the same time on the lower range, as you can see, we've got a 24 millivolt. This is great for measurement in circuit, because that 24 millivolt is so absolutely tiny current that is not going to enable any semiconductor that can be on the board, and you can make a very good measurement when you are looking for short without enabling PJ junctions or things like that. Here we've got the calibration for the resistance, for DC. Here we can reverse the polarity on modern digital meters when you are going to reverse the connectors. You are going to have a negative digit on the multimeter. Here you can reverse it, and you just basically swap the plugs around the probes, and it's going to show you the negative voltage. Here we've got for the high frequency, that's up to 1000 megahertz, and the low frequency, that's going to be, I believe, for the audio systems. And here we've got the banana connector for ground. As you can see, we do not have auto ranging, but from what I read in the manual, it have a very good protections against short overload without absolutely any damage. And it go like up to 2000 volts on all ranges for a short period of time. So you can, if you see that you are going to hit the end of the scale, then you know that you have to change and the meter should be fine. Absolutely great size. As a kid, I was having a tiny meter that was terrible to read. Here it is absolutely great, and the size of the meter is really big. As you can see, it have a absolutely great condition for age of this instrument. And yeah, this is how it looks like. The meter came with this pouch that you do not have to be worried about any animals, because that looks like a fox leather, so no worries. And we've got a lot of different accessories that we can take a look. The plan is that I'm going to divide that videos, and today we are going to take a look at the accessories, and then later we are going to test each of them. First things, that some of the parts are absolutely brand new and they are factory sealed. This is a peak-to-peak probe. This is a device that you can use to measure real peak-to-peak voltage. In general, you are doing those things on the oscilloscope, where you can set your cursors and see the real peak-to-peak value. In any meter like this, it's impossible. They are going to be calculated to be effective voltage. In this probe, you plug it, you've got the ground clip here. We are going to see everything in the detail, but that's the generic thing. Peak-to-peak voltage without oscilloscope you can do with this probe. Here we've got another interesting probe. This is a RF probe, and if you take a look at this, it's quite looking like a oscilloscope probe. That's the type of look. You've got the part that looks like this. If you remove the clip, it starts looking like an oscilloscope probe, and that's because this is for a high frequency. This is the model number, and as you can see, you can sample the voltage between 1 kilohertz up to 1 gigahertz, which is, like I told you, 1000 megahertz, 15 volt max. And I know that this sounds low, but there is an attachment that allows you to measure up to 500 volts. With this you can measure like with an 50 ohm load, like a handheld radio with 4 watts, and looks absolutely amazing. We are going to do all measurements, all the tests, so absolutely no worries. Here is a generic banana probe for testing the DC voltages, so you just hook it up here. I've got an open one here. No, that's a ground clip actually, and you can plug it here and you can hook up yourself to the chassis, to the device under test. Very nice. Here we've got the probe that I was thinking of. On one end we've got a BNC. We hook it up here, and we've got two banana probes. This is of course a coaxial shielded cable, and it came with those alligator clips that can help us with hooking up and doing measurements. This actually, I've got no idea what it is. It was included, but I've got no idea. Maybe some sort of K. Let's put everything back. That's not all, because we are going to do and take a look at the power supply. If you would like to use it as a portable meter, you put double ace batteries, and I believe it was holding a 10 or 12 double 8 batteries, plus I believe a 140 resistance, and we are going to take a look at this later. But if you would like to have it like in a benchtop configuration, there is my Voltcraft constantly plugged to power, then you purchase this unit and you are swap it out with the battery holder. As you can see, it has exactly the same form factor. And this is a power supply. This is a power unit, as you can see, 115 volts, 230 volts. You can, I believe this is where you can swap the correct voltage that is going to be hiding on one of the poles. This is for a 230 volt configuration, and you can use the European plug. This is the model number if you will be interested. So as you can see, they think of absolutely anything that you can imagine. You were able to buy for this meter to fit any need. Then we've got another thing. If you would like to probe a very high voltage, and this is a 30 kilovolt, 30,000 volt, if you need to probe that kind of voltages, you use this probe, and this is 1 to 1000. So if you read 1 volt, you are actually measuring 1000 volt, and you've got 1000 mega ohm resistance. Let's take a look at the probe. So it's going to have a hand guard, and this is how it looks like. It is factory sealed. No worries, I'm going to divide that video and I'm going to test everything. So I believe if we've got like some sort of flyback transformer for a CRT, the 30 kV will be enough for a flyback transformer. I hope I'm correct. And you can poke it and safely measure your voltage. We've got exactly the same BNC shielded cable, and there is a ground clip somewhere. There must be a ground clip, I believe I see it there. And what's that? This is a tip for the probe. You screw it at the end and you can poke around. So really nice. Here we've got something that you've got on almost all meters. We've got a thermocouple. This is a device for measuring temp. This is how it looks like, and the scale is also in the Celsius degree, so we will be able to measure the temp. I'm wondering, what does this button do? I believe it contains a mercury battery. That's why it looks so salty. We are going to open this and some video, maybe we can fix it, but I'm very afraid that the mercury battery that is require 1.35 volt is going to be impossible to obtain, and it's hard to come up with a modern replacement. But yes, you've got a probe and you were able to, maybe that's switching the battery. I think that's possible, but why it does not have any indicator? We're going to turn it into parts. Here we are going into things that are mostly interesting for any RF measurements. We've got the coaxial T connector, which stands in reality for sampling. This is basically a sampler for RF measurements. This is how it looks like. Does it brand new? I think it looks like it was never opened. So you've got that looks like a N connector to me. We've got two N connectors on side and this very weird looking hole, and you've got ability to see the center conductor. And in reality, you are grabbing this probe, you are removing the tip, you are unscrewing the protection cap, and you are screwing this probe inside. And this set will allow you to measure any radio frequency. You put a dummy load on one side or the antenna, and then maybe not the antenna, but maybe you will be able to measure then the reflected power. That's quite interesting. But in general, you just measure the voltage by sampling it here and the dummy load there, radio on one end. You can measure the output power by the voltage that is across the resistor, and I'm going to show you that in the detail. We are going to play around, and this is like a completely passive device. It has absolutely nothing inside. Here we've got a voltage divider for 500 volts, and it was never opened, so we are in the first one. This is how it looks like. The ratio is 1 to 100. And this is exactly what I wanted. You've got a drying agent. This is how it looked back then. That looks like that's absolutely amazing. And yes, that's exactly, this is a capacitance divider. This is for a high frequency up to 1 gigahertz. You can screw it on, you can replace it with this probe, screw it there, and then into the sampler, or just use it like it is, and you can probe your voltage at the transistor or on a RF circuitry. As you can see, we've got a crazy amount of things to try, and stay tuned for another videos where we are going to hook up a radio and try to measure something in real life, maybe compare the measurement across something from cheap China. We are going to see how they compare the device from the 80s and something more modern. And this is how it looks like. So thank you very much for watching. I hope you find that interesting. See you next time, and bye bye.